Rectangular printed conference badges of paper or laminated plastic are a familiar sight at conventions and meetings of all sizes. Printed and usually worn with a clip or a lanyard, conference badges often serve as an event ticket. By 2009, several large technical conferences offered hackable electronic badges as part of registration, like these from DEF CON, ranging from extremely simple LED blinky badges all the way up to fully functional cameras, radios, game systems, and more. Badge engineering, or badge life, is another way to get involved in do-it-yourself and maker movement electronics. Not all recent badges are electronic. One of these is a white vinyl 45 record. The audio track was an encoded message that was part of a puzzle participants could solve at the conference. This is a badge from the car hacking village at DEF CON. This badge plugs into the OBD2 port and talks to your car. This is a photo badge for development of the JOCO version of the badge we are working on in Phase 4 ground. This board is by Steve Conklin. Kits for the simplest electronic badge, the Blinky badge. It's just LEDs and batteries. The badge from the 2017 Hackaday Super Conference was an expandable, working digital camera. Here's the Layer 1 conference badge with the game controller that came with it. Some badges are more art than electronic. This skull-themed badge had an Intel Quark D2000, 8 switches, and 5 LEDs. It put out some clues on the serial port and lit up with the Konami code. But to make it do anything else, you need to reprogram it, and the Quark was then discontinued by Intel. The first and second Bender badges can be seen here. This open source badge is what our badges are based on, and we cannot say thank you enough to the &NotXOR team. Here's a set of badges from the Roots conference, which is for kids. It's held at DEF CON. These badges are packed with features. Check out this working prototype of the first version of our ongoing badge effort. This is JOCO Pirate Monkey Theme. Here's an example of an entry in a hackable badge contest. This is our DEF CON 17 badge turned into a Geiger counter, where detected radiation was used for a one-time pad cryptographic link over Zigbee. There's a demo and a write-up linked in the notes. Here's another badge hack with the DEF CON 18 badge. The modified badge is on the left and the stock badge is on the right. So what's the point of doing a badge? Having fun and learning how to work together, outreach and DIY maker awareness, and encouragement. And also because a badge can be a radio accessory and part of the human radio interface. One of the functions of the trans-ionospheric is to show channel acquisition health and status. Here's where we are today with this concept. Your radio listens for a list of channel assignments that are transmitted from the ground sat or payload in order to know which uplink channels are free and can be accessed. Now, a lot has to go right to get a channel assignment. Knowing how far the radio is getting into the process gives you better visibility and control. These are proposals. What we are talking about can also work for an HTML skin, a physical radio layout, and other UI expressions. As always, comment and critique welcomed and encouraged. If you see the first LED lit on the downlink, that means you have symbol timing. The second LED means you have frame timing. The third LED means you have successfully received and demodulated the physical layer header. This means that a lot has already happened and happened right. You've got symbol timing and frame timing, you've demodulated the pi/2 BPSK header, and now you know how to decode the rest of the payload. And you know where to look for the next physical layer header in order to continue your correlation. Now, we select an unused channel and transmit our request to use the downlink. This includes a signal-to-noise report. How well we can hear the downlink is used by the payload to determine how much forward error correction that we're going to need. At this time, we might be identifying ourselves to the payload and asking to use it. Now, I say might be because one can always just listen. When you want to transmit, you need to get a downlink channel. The choice of how long to reserve an unused channel is a good one. Should this process be done for every uplink frame? Or should there be sessions that time out after a while? The registration process can range from everyone automatically gets access through the transmitter to full authentication and authorization with list management, where only pre-approved operators can use it. The particular policy is up to the operator of the ground sat or payload. Perhaps the first LED on this side would be request transmitted. The second one would be successful authentication. And the third, successful authorization. Once you hear yourself in the downlink channel assignment list, then you are good to go, and you can transmit. We believe that if you can't hear yourself in the downlink, that your traffic should not be passed along. The payload is using the downlink signal to noise values that you report to assign you modulation encoding. So the LEDs along the top can give you an indication of how good you're doing, if you have any messages, what mode you're in, room requests, and more. So we need to make a software prototype of this type of user interface. So not just for the badge that we're making for Dayton, but for HTML5, for Python, hey, even in Erlang. And no, I'm not kidding. Sign up, submit it, and let's show it off. The user interface is the product. So let's see if this idea works for us.
The popularity of electronic badges at conferences has exploded over the past few years. These started off as simple flashing LED trinkets, or maybe something with a microcontroller and an infrared transmitter to shut off that noisy TV at the hotel bar. They've evolved into a complex environment of fantastic artistic designs, sophisticated programming, and networked games that allow the user not only to play something on their badge, but to interact with other conference goers through the badges. This complexity, though, means that, well, maybe the parts are more difficult to use, or they definitely require more development time. While working on the Phase 4 ground badge design, we've come up with a couple of boards to help those designing badges like this. One of these is a BMD 300 breakout board. This is a module from Rigato that's based on a Nordic system on chip with an ARM microcontroller and a BLE subsystem. This BMD 300 module was used in a very popular badge at DEF CON last year, and other folks have designed badges based on this. The software has been open source, so there's a good set of resources for anyone interested in this. In addition to the breakout board, we've developed a badge design kit. This will accept a BMD 300 module or our breakout board and has some of the same functionality that we've seen before on these popular badges. The ever-popular WS2812 LEDs, some switches done in video game format, an LCD, SD card for easy loading of images or other information. And this particular design includes two different power supplies. A buck design, which could use, say, 3 AA batteries, or a USB input if you're developing on your desk. It also has a boost supply. This, which is in testing right now, may give you just as much life as the 3 AA solution, but with only 2 batteries, which means less weight and a badge hanging around somebody's neck. So the badge development kit is our take on giving something back to the community. Here's a design that's, well, in process right now, but something that will allow others to develop badges that make use of existing software and allow interoperability across a wide number of platforms.
Phase 4 ground. Our mission is to implement an open source version of the DVB-S2 and DVB-S2X and generic stream encapsulation protocols for amateur radio for both space and ground. All the digital video broadcasting protocols that we are working with can be found for free at dvb.org and from links on our homepage. Note that the use of GSE, generic stream encapsulation, allows any digital data to be transmitted. We are not implementing a system limited to MPEG video. DVB World Conference is coming up. If you're near Warsaw, that's where it's at for 2018. Our reference design is in GNU Radio, and we have some of the blocks done. We need plenty more, and upcoming videos will go into detail for each one.